introduction key. In this video, we will go over setting up static routes on 3 Cisco CISCO2901 routers with a desktop PC on each end.
Okay, so in today's brief lesson, we're going to go over setting up static routes on the Cisco 2900 router. Okay, so to start off, we'll look at the network, and the network today consists of 2 PCs on either end, and their names are also their IP address on their Ethernet 0 of each of them. So we have the first PC, and we'll take a look at the details. So we click on it and look at the global settings, and in the global settings we have the PC name, which is 10.0.1.2, the interface that it's on, which is Ethernet 0, the kind of IP address that we're setting up, which is the static IP address, and this is the static IP address of the gateway. So it's going to be this 10.0.1.1 is the gateway address of the router that the PC is connected to. To find out what the PC interface is, we go to the settings on the interface, and this is where we find the settings, and we enter in the settings. These are all been pre-configured, and this is a as I say, the PC for the lab. So the PC for the lab has a /24 address, which is the 255.255.0 bit mask, and the IP address is 10.0.1.2. So we're going to today we're going to look at the if you will, the theory of static routes on a router. Right now, these routers are not routing any traffic at all, and so to make it route traffic, we have to put a routing protocol on there. And right now, we are dealing with the simplest routing protocol, which is static routing. And in order for us to talk to PC, the PC on the far end, PC number 2, which has the 20.0.1.2 address, is we have to put in static routes. So we have to tell each router a hop by hop description as how to find this PC, and we have to do the reverse for this PC number 2 to find PC number 1. So first up, the routers have to have IP addresses on their interfaces, and to do that, we have to basically address these guys. And what we're doing for each router to conserve IP space, we're going to give them a /32, which is a you'll see right here on the router configuration. You notice the bit mask is different. It's for the router's interface to the other routers. Gigabit 1 is this guy here, and as you can see on the diagram, also I've also placed it. The route the subnet mask is 255.255.255.252 /32, and the /32 basically gives you 2 usable hosts. And so what you have with the /32 is a network of 30.0.1.0, and that .0 is the network, and the broadcast for that is going to be let's see, the broadcast is in this particular case would be 3. Okay, so not to get into that too much more, what we have to do is we have to basically tell this router how to get to this PC on the far end, and the opposite too. So in the static routing, you see how we put down IP route 20.1.1.0, which is how do I get to that network on the far end, anything on the far end. So we're looking at the entire /24 of this 20.0.1.0, and so we're going to go in the router and say, okay, well, what's the next hop? How do we get there? And that's going to be the egress interface here between these two guys, which is the 30.1.2. Sorry, the 30.0.1.2. And if you notice, with the next router, we're still asking, it needs to know, well, how do I get there? So it gives the IP address of the next hop on that router, and it goes up to this guy, and he does the same thing, and he finally gets to the host destination here. He has a route to the actual host, and we do the opposite here. We're asking from this side, how do we get to the network, the 10.0.1.2 network? How do we get to that network? And as you can see, the static routes, next hop here again, the 10.0.1.0. It looks and it says, okay, it's the 30.0.1.1, and so on until it gets to this guy. So let's put that configuration on here and make this a quick lesson. So we'll get in here and hit enter, go into enable mode, and we'll type in config T. And now we're in configuration mode, and what we're going to do basically is we're going to just, for the sake of making this a quick lesson, we're going to copy the configuration from here, and so we're going to configure all the interfaces, and basically let's just make copy, just Control C. So we're going to configure all the interfaces, and we're going to paste them in the configuration here, and that should basically let's just show you the configuration first, and we can do a do show run to show the configuration, and you can see that there's really nothing on here right now. All we have are the interfaces. This one has some extra interfaces, but all the interfaces we're going to deal with is the gigabit 0/0 and the gigabit 0/1. So now we're going to paste that configuration in here, and the interfaces should come up. And so they did. So see, the first interface is the one facing the PC, and that's the 10.0.1.1, and the next one is the interface facing the other router. So now they're up. And what we'll do is we will do a Control Z and do a write mem to write the configuration, and we can do a show IP interface brief, BRIF, and that shows the two interfaces now that's been configured. They're up. The protocol is down on the second interface, which is the interface facing the next router, but the protocol is up on the interface facing the PC. So this is something you should always notice, is that the interface can be up, but the protocol can be down. And we usually call that in the business an up-down situation. You want to always have an up-up, that the interface is up and the protocol is up. That means that you're talking. So we're going to go to the second router, and we're going to do this ahead of time. We'll basically copy this configuration, and we'll go into router 1 and hit enter to wake it up. Go into enable, type, and you can just type conf T actually, and we're going to paste the interface, the configuration information in here, and now we're up, and we can do a do show from the configuration mode, run. And now we can see the configurations changed with our static routes down here, which would be the same thing for the other guy. And we can also do a do show IP interface BR, and you can do a BRI on this router. Some other routers won't allow you to do that. You have to type in the whole BRIEF. But as you can see, again, this router says my interface is up and my protocol is up to the first router, but to the last router, his protocol is down. His line is up, but the other guy isn't talking to him, so his protocol is down. So again, we'll do a Control Z here, and we will save this right now. So now this guy is saved, and he is good. And we go to the last router, do the same thing. We're going to copy this information, and we're going to paste it in here. And we'll go to the CLI, hit enter, enable, and CLNFP, and we will paste the information in here. And as you can see, up. We'll do a Control Z and do a right mem, and we'll do a show IP interface brief. All right. And now you see everybody's up. Okay, so the interface from router 2 to router 1 is up. So the routers are talking to each other in this case, and we'll go to the other routers and just take a look and do the same. So this router now should be talking to all the other routers. As you can see, while we were away, the line protocol came up on this router. So if we were to hit enter on this guy and do an up arrow, well, it's not in the history here, so we have to do show IP interface brief. And now you'll see that the router is talking to both routers now. This router in the middle is talking to router 0, and it's also talking to router 2. So all the interfaces are up, okay? Now, and we'll go to the last router just for consistency and take a look there too. And as you can see, while we were away, its interface also came up, so it should be talking to everybody also. So we hit enter to wake him up, and we type show IP interface brief, and now you see that he's up. Now this router just so happens I placed in there a extra module, which is a switch module, and although all the interface interfaces are up on the switch module, there's nothing connected to it, so the protocol is down on all those modules. And this is something we're always seeing here, is this VLAN. We'll get into the VLAN later. It's administratively down, but we will get into it in future lessons. So now all your interfaces are up, okay? So what we're going to do is we're going to go to my favorite PC number. This is PC number 1, and we're going to go in here, and we're going to go to desktop, and we're going to go to command. And what we're going to do is we're going to do a trace route, and this is how it's done in the real world. We're going to do a trace route from the PC, from PC number 1 to PC number 2. Now, this is the command. It's called TRACERT, and then you're going to put the destination IP address that you want to get to. In this case, it's 20.0.1.2. Now, the first time I do a trace route, it's going to take a while, because what's going to happen is that the routers are going to have to actually look up their routing tables and see the static entries that we put in there and realize how to get to it. When it does that, it reads everything. So the expectation is that when we do it in the opposite direction, it will be quicker, because now the router has actually learned it. And that's kind of interesting. We never thought about it, but routers learn things and remember it. Okay, so now I'm going to hit trace route, and it's going to the gateway, which is the 10.0.1. Now it finds the next hop from there, which is the 30.0.1.2, and then it found the last hop, which is the 40.1.2, and now it gets a response, and it says trace route complete. And now if we go to the other PC and do the same thing there, it should be quicker. It should be almost instantaneous. So we're going to do a TRACE, a trace RT, and I hope I spelled that right. And it's going to be to 10.0.1.2, and it should be almost instantaneous. See, boom, 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 it's done, complete, trace complete. That means now that the routes are known by the routers. Now, because that's established, we're going to look in the routers this time, and we're going to see what the router thinks about all of this. So we're going to do I'm going to just wake it up again, and I'm going to do a show IP route. And notice what the response is. The legend up here, when you do a command like this, and you do a show IP route, you get a legend, and there's a whole lot of stuff going on here. And the L means local, C means connected, and S means static. So if you look here, it says that the routes that are known by this thing is a /8 for the 10.network. But it knows that locally connected, directly connected on gigabit 0/0 is a /24, and it's a 10.0.1.0/24. And then it says directly connected to it is the actual IP address of the interface, which is the 10.0.1.1, which is the gateway that the PC uses to get out. Okay, this is the gateway. And then it also knows that there's a network on the other side. There is a 20.0.0.0/24 network with one subnet on there, and that subnet is this guy. And it's statically defined by the router as the 20.0.1.0/24 network, and it's known via the next hop, which is the interface of this guy to this guy. Okay, that's their interface. .1 and .1 and .0. Sorry, .1 and .2. Okay, and this guy here is similarly 40.1. And it looks like he is, oh well, that's a typo. He's 40.1.0.1.0/32, which is a .1 here and a .2 here. Anyways, so this is how you read the output from your show IP route. You look at the locally connected, and you look at the static entry, and you look at how it's known, and that's usually the next hop information. Okay. And we go over to the next router, do the same thing here. We'll do a show IP route, and you only have to type RO. Really, it knows what you're asking. And again, so in this case, you'll see no reference to the PC, but you see references to the networks that it knows. See, now it knows that the PC number 1 is on this network, the 10.0, and I'll just highlight that here, right? The 10.0.1.0/24, and it's known via this guy going back. So if you look at it, if you look at east-west, on the west side is 30.0.1.1, okay, which is the gateway for this guy. And if you look at it from the east side, you see that he knows the other network, this guy here, via the because we're in the middle now, so he knows him as the .2 interface on this guy, on this router. All right, and you can basically go over this and say, oh, okay, connected, locally connected, and this type of thing. You can see all the subnet masks and the like. So I would say, if this is where questions would be asked, this is a good place to look at and ask me questions about it if you don't understand all the details, because basically it's telling you what's going on here, because it's saying that it knows on this router there's directly connected these interfaces here. Okay, we go to the last router and do the same thing, and I think let's do this. Wake it up. Do the show IP route, and you can see now. Okay, statically defined is going to the west. Okay, the statically defined interface, or the statically defined route back to PC1 is westward bound. Okay, and he knows how to get to him, at least the first hop, which is the first interface on this guy to get back to here. Right, so this portion is on the outward bound portion up here is this 40.1, and he talks to the 40. When I say 40.1, I really mean 40.0.1.1, and then his .1 talks to his .2 on the middle router 1 here. And that's how the routes are known both ways. And then you can see, if you look at the eastward portion, he knows he's locally connected to it. He knows he's locally connected, directly connected to that interface, and he knows that this network, which is this network, the 20.0.1.2 network, is there, and so he'll find whatever is there. Brief lesson, quick, but this is something that I will give out to my students, and they will basically, this is the homework, guys, is to reproduce this network. And I would say, for your step-by-step, I would say put in the commands one by one. I just did it this way. I did it this way just for brevity, to be brief, to be quick. I don't want you guys falling asleep and drooling. So basically, this lesson, what we did was configured static routes. We showed that for anything to work, you have to basically define both ends. And just as the final part here, normally we do a ping, and we will ping the remote guy, and it should be almost instantaneous. So there we go. It's like boom, boom, boom. Ping works. We also established the trace route, which is the next hop behavior. It tells you how this guy gets to where he gets. Okay, and we're just doing it for like a sanity check. We do the same thing on this guy here, and also a little trick you can do. You can just basically backspace it and just type ping right here and hit enter. It doesn't care if you go back to the beginning. And this tells us again that we have a good connection. It knows the trace route from the PC, the trace RT command, showed you that it knew how to get there, obviously, and the ping just confirms that this guy can talk both ways. Okay, that's what the ping does for you. It says we can talk both ways. So that concludes today's lesson, and the homework is to configure this network with the routers, and get the same results and do the same tests that I did. Okay, do the show IP route on the routers once everything is set up, and do your trace RTs from both PCs in the lab. And if you can get everything working like that, you have actually accomplished something.
So there you have it. Your challenge is to configure the static routes and interfaces on these routers. Use Cisco Packet Tracer. Good luck. This is Function Key.